Hello and welcome to today's demo. As part of 2404 Oracle integration release, we have shipped two AWS Services Adapter, which are AWS SQS and AWS S3. These adapters help OIC to integrate other AWS services seamlessly. So let's quickly go through these adapter features. So as of now, SQS adapter supports invoke. It supports operations such as create, delete, list, purge, tag, and untag of the queues. Enables service send, delete messages from the queues, modifying and retrieving the queue attributes such as visibility timeout, maximum message size, etc. And it enables the dead letter queuing. It supports Amazon signature version 4 security policy. And in upcoming releases, we were planning to support XML messages to and from the queues and inbound polling and the connectivity agent. From the S3 adapter perspective, this adapter also supports inbound connectivity, supports objects and buckets of the storage entity. Suppose put, copy, get, delete operations, and list. Allows attachments, and then it support Amazon signature version 4 security policy. As part of the future support, we're going to support connectivity agent. Let's now review the use case for today's demo. So the use case is to demonstrate the OS's capability of multi-cloud integration. So we have Primavera Cloud on OCI and AWS SQS and PostgreSQL on AWS Cloud. Using OIC, we'll be integrating all these applications across the multiple cloud infrastructure. So OIC extract the activities of a project from Primavera Cloud and then publish the activities to the AWS SQS. OIC consumes the messages that are available in the AWS SQS and then insert the activities into PostgreDB, which is hosted on the AWS. Let's now go into the OIC and see how this use case is achieved using the Oracle integration. So as I mentioned, I have two schedule-based integration, one to extract the project details and activities from the Primavera Cloud to SQS, and the other one is to consume the messages from the SQS queue and then post it to PostgreSQL. So let me first execute schedule-based integration to extract the project activities. Before I run this integration, let me go into the AWS SQS queues and then showcase whether we have any messages that are already available in this particular queue. So I'm using this Primavera project activity queue.fifo for our integration. So let me click send receive message. I see there are no messages available over here. So let me go ahead and execute the integration. So I've given the project ID as an input here. I can see the message successfully executed. Let us now go inside the SQS and then check whether we have any messages that are available here. I will click send receive message. I can see one message is available over here. So let me poll this message, take the content of this message, and it has two activities. Now let's run the second integration to consume the message from the SQS, which we have just inserted using the first integration. So before I go ahead and run the second integration, let me take you to the PostgreSQL. So this is the table which I'm using to insert the data. So let me run this one. I see there are no messages available. Let me go ahead and run this integration. I can see the message successfully processed. Let's go to PostgreSQL, run this particular query again. We have seen two activities in the message, and I can see two rows that got created in the PostgreSQL. So one more important point to note here is right after the messages that got posted into the PostgreDB, we are deleting these messages from the SQS queue as well. So let me do a poll message. Currently you see one, and now the integration successfully executed. So I'm polling the message again here, whether it has been deleted or not. I can see 0 messages that are available. Let's now see the design term of this integration. So this is a schedule-based integration. I'm invoking Primavera Cloud Adapter to pull the activities of a project, and I'm invoking SQS Adapter to send the message to the SQS queue. So let's quickly go through the SQS Adapter. It has multiple resources: queue administration, message, message move task, and permission. I've used message resource over here to send the message. It has multiple activities: receive, delete, send, and change message visibility. So right after you select the send message, it will ask you to select the queue to which you wanted to send the message, and this is dynamically be populated as per the connection configuration that you have done. You can upload the JSON sample over here. You can even encode the message and you can configure message attributes. The same way, you can even receive the message, and once your activity has been completed, you can even delete the message if required. You also have a dead letter queuing option in case if there is any message that got stuck due to the network issue or any other issue. So the message was not pulled from the actual queue. It goes into the dead letter queue, and you can design one more integration to move the message from dead letter queue to the actual queue. So you can provide source ARN and the destination ARN, move the dead letter queue message back to the original queue so that actual integration can again pull the message from here. So let us go into the other integration. As you know, this is also schedule based integration. Here we are using SQS adapter to receive the message. In the previous one, we have sent the message. So hence I have selected the receive message action over here in the message resource, and I'm invoking the PostgreDB. So I'm inserting the data into the PostgreDB here. So I've selected the table. It is more or less similar to other database adapters, and then posted the message. And as I mentioned, after I post the message successfully into the PostgreDB, I'm invoking one more action of SQS to delete the message from the queue. Let's also quickly review the SQS adapter. You should have to provide the AWS region. We support AWS Signature version 4 security policy. That's all from our demo today.